welcome you all back to my new lecture on simple hydraulic circuit working and its simulation. Before proceeding to the working of the circuit, let us understand the components displayed in the circuit. First you have the tank. This symbol is representing a reservoir which contains the hydraulic oil or a tank. Again, this is going to be the same tank. Instead of showing the pipelines extended to the same place, for simplicity they have shown here and also here. So this saves or this avoids confusion when you understand a hydraulic circuit. Any place of the hydraulic circuit where you find a reservoir like this means everything goes back to the tank. After the tank, a gear pump takes suction and then it presses up the oil directly up to this control valve, that is the direction control valve. You have a pressure gauge here to tap the pressure reading and a safety relief valve to relieve the excess pressure back to the tank. This is the downstream of the direction control valve. Now on looking at the upstream, that is this side of the direction control valve, you have a piston which is going to lift a weight up and down and pressure tappings at both the ends of the piston. So you can see the piston here with O-rings. So this is going to move up and down and perform work by lifting this weight. You have pressure gauges here which is going to read the pressure when doing such work. Here you have a graph which is going to indicate the pressure inside the system and its behavior. Now let's start with a neutral position, that is these ports are blocked, the center blind position, which means no oil can flow past to the upstream of the direction control valve. These are two buttons, which means this valve can be operated either by solenoid or by manual. Here, since I'm going to operate and show the simulation, it's going to be manual operation. Let's see how it works. I'm going to start the simulation. Let's watch it step by step clearly. As I start the gear pump, it takes suction and the oil under pressure goes here. Now there is no path for the flow of oil and thus the system pressure builds up. It relieves, or the excess pressure is relieved through the relief valve back to the tank. This continues happening till there is any change in this position of the valve. There is no return oil coming back to the tank because this is also blindfolded. Now what I'm going to do is I'm going to increase some weight here. So as I increase a little bit of weight, the pressure required to lift the piston will be slightly more. Let's see how does that work. We have to click here to raise the piston up so that it lifts the weight. Now I'm going to do it, click to raise. As I do it, the valve position changes and then the oil flows and then the piston rises up. As you can see, the oil from here follows this channel and it goes underneath the piston, pushes the piston up, and on top of the piston, if there is any oil, that will get relieved back to the tank. This is how the system works. You can see the pressure here. Pressure here reaches maximum pressure, after which no more oil will flow, where the safety pressure relief valve safeguards the system and thus avoids any rupture of the pipelines. As you can see, the gear pump continues to work and then excess pressure is relieved back to the tank. Note that the pressure near the piston and pressure after the pump is almost same, whereas the pressure here is 0, which means there is no oil pressure on the return line. Now on looking at the graph, this shows the rate of rise of pressure to complete the work done in lift of the piston for this particular weight. Now I'm going to put it back to neutral position. where the pressure drops immediately because there is no more flow of oil as all the ports have been blanked. Now the pressure starts to fluctuate and you can see the piston slowly starts to drop down because the weight is going to compress the oil and increase the pressure here. I will show you with a little bit of more weight. I'm going to add up the weight. When I add the weight, you can see there is a drop in pressure and slowly the piston starts to come down automatically even though the ports are blanked. This means the oil beneath the piston is getting compressed, and you can see that by there is an increase in pressure. This is also evident through the graph. The oil above the piston, which was under pressure, gets expanded now. Now I want to lower the piston, so what I'm going to do is click on this. As I do that, the oil flows directly on top of the piston, which is indicated by the pressure here, pushes the piston down, the weight goes down, and the oil which was underneath the piston drains back to the tank. Now on top of the piston this is full of oil and the piston can no more go down. Thus the pressure relief valve or the safety valve lifts and drains back to the tank. Now I'm going to increase further weight. I'm going to put it full load. Now let's see how does this work. I'm going to raise the piston up. Now in neutral position. Now I'm going to raise it up. Now you can see the pressure is fluctuating so bad because the weight is maximum or the load is maximum, and the time taken to lift the piston up is more than what it was in lighter loads. Again, after lifting up to the topmost position, the pressure reaches maximum, which is same as the line pressure, and then the safety valve lifts and relieves the excess oil. Now I will bring it back to neutral position, and due to the excess weight you can see that automatically the oil is getting compressed and the piston drops. So let's lower it now. You can see since the load is high, it will lower very faster. The drop is much faster because the load on the system is too high. So even by gravity it can easily come down. Let's once again see how does it rise. Bring it back to neutral. Both the pressures are 0. Now I'm going to lift it up. Now the oil starts to flow underneath the piston. Let me reduce some mass. As I reduce the mass, you can see the piston goes faster. Now I've kept it at the lightest load, and let's see how fast does it take to lift up again. Okay, I'm going to lift it up again. This is in neutral position. It will be too fast when we compare it with full load. You can see the graph rise immediately and the piston reaches top within very short time. So that's the basic understanding of any hydraulic circuit which requires to operate with load. Hope this explains you the basic operation of the hydraulic system.